What if I told you that one of the most hostile places in our solar system might still inspire the idea of alien plants? How could anything green possibly survive on Jupiter, a planet with crushing pressure, violent storms, and no solid ground? At first, the answer seems simple. Plants couldn't survive there. Case closed, right? Well, not so fast. Jupiter is the largest planet in our solar system, more than 1,300 times bigger than Earth. But unlike our home planet, Jupiter is mostly made of hydrogen and helium gas. There are no forests, no mountains, and no solid surface where roots could dig into the ground. So, how could plants survive on Jupiter? To answer that question, we first need to understand what plants actually need. Plants on Earth depend on three major things: energy, nutrients, and a suitable environment. Sunlight powers photosynthesis. Water and minerals provide nutrients, and gravity and soil give them a place to anchor themselves. Jupiter immediately creates a huge problem. Its upper atmosphere reaches temperatures as cold as -145 degrees Celsius. Deeper down, temperatures become incredibly hot, reaching thousands of degrees. Winds race at more than 600 kilometers per hour, and gigantic storms can last for centuries. The Great Red Spot alone is larger than Earth, not exactly a gardener's paradise. But what if life didn't look like the plants we know? Scientists who speculate about exotic forms of life sometimes imagine floating organisms inside Jupiter's atmosphere. In the 1970s, astronomer Carl Sagan and biophysicist Edwin Salpeter proposed hypothetical creatures living high above the planet's crushing depths. They imagined enormous balloon-like organisms drifting through layers of gas. Smaller organisms might feed on chemicals in the atmosphere, while larger ones could float like living jellyfish. Could plant-like organisms do something similar? Perhaps. Instead of roots buried in soil, these strange plants might have gas-filled structures that help them remain suspended in regions where temperatures and pressures are more favorable. Instead of absorbing minerals from dirt, they could gather chemical compounds directly from the surrounding atmosphere. And what about sunlight? Jupiter receives only about 4% of the sunlight Earth gets because it's much farther from the sun. Yet some sunlight still reaches the upper clouds. Hypothetical plant-like organisms could develop enormous surfaces to capture every available ray. Think of giant floating leaves stretching across the sky. But could they use something other than sunlight? Absolutely. On Earth, certain bacteria survive through chemosynthesis, obtaining energy from chemical reactions rather than sunlight. Deep-sea ecosystems near volcanic vents thrive this way. Alien plants on Jupiter might rely on chemical energy instead of photosynthesis. They could harvest energy from hydrogen, methane, ammonia, or other compounds abundant in the atmosphere. In other words, they might behave more like a cross between a plant and a microorganism. Of course, there are still enormous challenges. As organisms drift downward, pressure rises dramatically. Deep inside Jupiter, pressure becomes millions of times stronger than Earth's atmosphere. Eventually, hydrogen transforms into a strange liquid metallic state. Any Earth-like plant would be crushed long before reaching those depths. Radiation presents another obstacle. Jupiter possesses the strongest magnetic field of any planet in the solar system. Powerful radiation belts surround the planet and could damage delicate biological structures. So, if plant-like life existed, it would need extraordinary defenses. Maybe thick protective layers, maybe self-repairing tissues, maybe biochemistry completely unlike anything found on Earth. And here's something even more fascinating. Scientists are actively searching for life beyond Earth by asking a simple question. Not, where can Earth life survive, but what kinds of life are possible? That change in thinking has opened doors to incredible discoveries. Life has been found in boiling hot springs, acidic lakes, radioactive environments, and deep beneath Earth's surface. Organisms called extremophiles continue to surprise researchers by thriving where nobody expected. If life can adapt to such extremes here, perhaps the universe contains forms of life we haven't even imagined. Could floating forests exist in Jupiter's skies? Could giant airborne organisms harvest chemical energy while drifting among colorful clouds? Nobody knows. At the moment, there is no evidence that plants, or any life, exist on Jupiter. But the idea challenges us to think bigger and reminds us that nature is often more creative than we expect. Maybe the real question isn't whether plants could survive on Jupiter. Maybe it's whether life throughout the universe follows rules we have yet to discover. But suppose Jupiter itself isn't the only place where strange plant-like life could exist. What if the planet's enormous system of moons played an important role? Jupiter is surrounded by nearly 100 known moons, forming a miniature solar system of their own. As these moons orbit the giant planet, they interact with its immense magnetic field and powerful gravitational forces. Together, they create a complex environment unlike anything found elsewhere. Could this activity provide unexpected opportunities for unusual ecosystems? Imagine microscopic spores drifting high above Jupiter's clouds. Instead of remaining trapped forever, some might be carried by electrical currents and eventually escape into space. Tiny particles are constantly exchanged throughout planetary systems. Dust, ice, and charged material travel vast distances, sometimes reaching neighboring worlds. Could living particles survive such journeys? On Earth, certain microorganisms can endure extreme cold, dehydration, and even exposure to the vacuum of space for limited periods. If alien biology evolved with similar resilience, perhaps Jupiter's atmosphere could serve as a nursery for organisms capable of spreading across the Jovian system. And then there are the lightning storms. Jupiter experiences electrical discharges far more powerful than those on Earth. Some lightning bolts release enough energy to illuminate huge portions of the atmosphere. These storms may drive chemical reactions that continuously produce new molecules. In a strange way, the sky itself could act like a giant laboratory. Complex compounds might form and break apart endlessly, creating an ever-changing supply of ingredients. Over millions of years, perhaps this chemical chaos could encourage increasingly sophisticated forms of life. Maybe entire generations of floating organisms would evolve in response to the planet's turbulent weather. Some species might thrive in calm regions. Others might deliberately ride violent storms, using powerful updrafts to transport themselves to higher altitudes. Some could reproduce by releasing millions of tiny seeds or spores into the winds, allowing Jupiter's atmospheric currents to carry their offspring around the planet. Over time, isolated populations might evolve into completely different species. Imagine vast belts of colorful organisms stretching around the planet. Perhaps one region would glow with brilliant blues, while another would shimmer with deep reds and golds. Pigments unknown on Earth could absorb wavelengths of light invisible to human eyes, turning Jupiter's skies into an ever-changing ocean of living color. Communication between these organisms could be equally strange. Instead of flowers attracting insects, perhaps they would emit flashes of light, bursts of radio waves, or subtle electrical signals carried through the atmosphere. Entire communities might synchronize their activity, creating massive pulses that ripple across thousands of kilometers. To an observer from space, these patterns might resemble natural weather systems, yet hidden within them could be the signatures of life. Would we even recognize such signals? That question lies at the heart of modern astrobiology. Human beings naturally search for familiar signs: oxygen, water, green leaves, and carbon-based chemistry. But alien life may not advertise itself in ways we expect. Perhaps life elsewhere doesn't produce forests. Perhaps it doesn't produce animals. Perhaps entire ecosystems exist that blur the distinction between organism and environment itself. Jupiter challenges our imagination, because it forces us to abandon assumptions shaped by life on Earth. Maybe somewhere in the galaxy, there are worlds where clouds are the oceans, where storms are migration routes, where the sky is both habitat and home. And perhaps, among those endless alien skies, there are forms of life that have never touched the ground because they never needed to. For billions of years, they may have floated peacefully above worlds we would consider impossible. And if such creatures exist, they would remind us of something extraordinary. Life does not necessarily adapt the universe to itself. Instead, life adapts itself to the universe. And the universe, it seems, may have far more possibilities than we have ever dared to imagine. So perhaps the story of plants on Jupiter isn't really about Jupiter at all. It's about the limits of our imagination. Because every time science explores the impossible has a habit of becoming slightly less impossible. And somewhere beyond the familiar, hidden among strange worlds and alien skies, nature may already be writing chapters we have not yet learned how to read.